Hi, how are you doing?
I'm good, thank you. How are you?
Very good, very good. Yeah, so are you getting this concept of integration?
Yeah, it's going good. I've been doing some questions for my book,
Okay.
so it's going well so far. When I get onto the mix section where they do like all the topics in one go, then that will show where I'm finding difficulties. Because now I'm just doing it like topic by topic. So
Okay. Yeah, that is true. So when they come to an integrated approach, it might just become slightly difficult. Well, anyway, I think you're well prepared and you can take on those questions also. No problems, right? So now we are also in a very critical stage. We have learned basic concepts about integration, and we do understand how to integrate the functions, and we also understand how integration and differentiation are related with one another, right? And we can actually do integration by antiderivatives, and we also have this concept of area,
mhm,
which could be easily found by integration, right? We have also
right.
learned about the fundamental theorems. So let's begin our class with the foundation which we have built, and then from there we'll build on. Okay. So let me share with you the screen. So there, today our focus, Abby, will be to find the area between the curves, right? So we'll get to area between the curves, which sometimes is the most difficult question in your test paper. So let's review what we have learned so far. We know that if f is a positive continuous function, then f of x can be interpreted as area under the graph of f, right?
Mhm,
So that is one thing. That is to say, this graph which you see right there can be interpreted as the area, right? And we also know that rate of change of area is actually equal to the function itself. And if we do antiderivative, we can actually find the area. So area basically is a definite integral of the function within two limits, upper and lower
mhm,
bound. And the condition is that the function should be continuous in this particular area. And we are also assuming when we talk about area that the function is positive, right? Now, from here, we know that this fundamental theorem of calculus part one, if f is continuous in a closed interval, then f can be defined as shown above as the integral between a to x between when x is between a to b, right? So here you can actually calculate the integral by finding it is an antiderivative of the function itself. So we
mhm,
have an easy way of finding this integral, right? And in fundamental theorem of calculus part two, we discovered another easy method, and that was that if I find the difference between the values of f of b and f of a, I get the integral itself, right?
right.
So that is what we have learned so far. And in this particular case, what is f? F is antiderivative of the function. So we'll now use this concept to solve some questions. So I'm taking actually very simple example as usual. Basic idea is to understand the concept, correct? So we'll
Mhm, yeah.
begin with lines, such a friendly example. So example one, we did take similar example earlier also. You can compare the approach now. So earlier what we did was we did do antiderivative. We had a factor plus c, and putting the initial conditions, we found c and then calculated. Correct? That's
Mhm,
what we did. Now, using this fundamental theorem of calculus, we can easily find. So the question for you is, find the area of the shaded region shown under the curve f of x equals to 2x plus 1 from x equals to 1 to x equals to 2.5, bounded by the x-axis. So we are only looking into the upper portion of x-axis, right? So this positive part, right? Area is
mhm,
positive, right? Now, from the fundamental theorem, we know it is antiderivative of the function itself, right? Which is 2x plus 1, correct? So we
right.
wrote area is the integral from 1 to 2.5, the limits given to us. And to find this integral, we'll do antiderivation. So 2x will be x squared divided by 2, 2 and 2 cancel, we get x squared, 1 is x. And using the second uh, fundamental theorem of calculus, We are just finding the difference in these two values, correct? So when you substitute 2.5, you get one expression. Substituting one, you get the other expression, and their difference gives you the area. So the area is 6.75 square units in this particular case, correct? Now, is this process clear to you?
Yeah.
Absolutely clear. We'll take another example, which is parabola, but exactly similar question. Again, now the question is, find the area of the shaded region shown under the curve. The function here is 20 minus 3x squared. We are again given the limits minus 2 to 2. As you can see, the function again is positive, no problems at all, bounded by the x-axis. So just write down the function, take its antiderivative, and within those two limits, fb minus fa gives you the area once again, right? So we get 20x minus x cubed, which is the antiderivative, and fb minus fa, we get the values. And so there we go, we get the area, 64 square centimeters in this particular case. Now you see, sometimes in your book, you might have questions which will combine this with slightly, they'll add some complication, right? They may form a triangle here, for example, right? Something like this. And, then maybe connect with this particular point, correct? And they may like to find the area of the portion like this. You understand?
All right.
So that could be a variation. That is to say, in that particular case, what you need to do is you have to take away this area from the total area, correct?
Do you just follow the same process?
Same process. So sometimes they will just complicate the questions. They'll make some triangle. And you also know that area of the triangle is half AB, right? Half base into height, correct? So you could use a combination of the triangle and what we are finding, area under the curve, to solve those questions. Is that clear, right?
Yeah.
So I haven't included any of those in my set. However, that is the technique, okay?
Okay.
Now we'll actually focus on area between the two curves. While in all my examples till now, we are using positive side, upper half of x-axis, just keeping them positive, but they could be negative also. If the values are negative, you just have to take the absolute value. That is what it is, correct? So it makes no difference. That is what it is. Yeah. So in example 3, the question is, find area of enclosed by the function, which is x squared plus 1. This is a parabola, which is shown in this blue, and the line g of x equals to x. So between these two, I've shaded the area for which we are interested in. We are given the closed boundary condition, x equals to 1 to 3. So again, same process. However, this time, since the area is between two graphs, it makes sense that we find the difference between the two functions, right?
Right,
between two functions, the function, new function will be difference of these two functions, right? So f of x minus g of x give us the function which is in between these two functions.
So how do you know which way around we're like subtracting, like f of x by g of x?
If it is the other way, yeah, if it is the other way, it doesn't matter. The only thing is when you calculate, you get a negative answer.
Oh, so you just take the absolute value.
And you take the absolute value. So basically, you have to take the absolute value when you're trying to find the area. That is
okay.
So even if you write gx minus f of x, it doesn't really harm much, right? Because you're right, always it may not be so easy to, sketch your graph and things like that. Correct? Now, that is the case. Sketching graph here helps because we also come to know from this particular diagram that these two graphs are not intersecting in between, right? Because I could have had a line which could go like this. Correct? In that case, the area between the two will be this area. You got the idea?
Oh, because it has to be like apart, in between these.
In between the two, right? Now this question is much simpler. It gives you the inner, the two boundary lines, and so you could easily work without thinking much because you know the points. Now the question is, we just changed the equation of the line. You could take this as another question. let's say we have a line h of x, which is equal to, let's say, x plus, let's add 3 to it. So if I take a straight line which is like moved 3 units up, definitely it is going to intersect as shown.
Mm-hmm.
In that case, this is what we are looking at. Now, in this case, what will you do? Tell me. You need to find the area shown by the green shaded area. How will you do this one? We are not giving you this value. Yeah.
Oh, so then would you have to find those points of intersection?
You're right. Absolutely right. So in that case, you don't know those points. So you have to find these points of intersection. So you equate f of x with h of x, right?
Oh, yeah. Make them equal to each other. Yeah.
Then you get these 2 points, correct? And
right.
when this difference of the two, you are working with the function which is in between the two.
Mm-hmm.
And find the area just as we are trying to figure out now. Correct?
Yeah.
And if you have placed the functions the other way, you'll get the negative answer. But remember, area is an absolute value. So in that case, take the absolute value. Is it clear?
Yes.
That is the concept. And we were actually getting there. Good you asked us. So next question you should do yourselves. Here is a question where
Great.
right? We have a line, we have a function, we also have a negative part, we have a positive part. And the question here is, can you please read the question for me?
Yeah, so finding the area between curves. Example 4. Find the area enclosed by f of x equals to x cubed plus x squared and g of x equals to 2x.
Correct. Tell me, how will you solve this question?
So since the limits aren't given,
Yeah.
I guess we would have to find the point of intersection.
Perfect.
It helps with the graph shown there. So we know by the graph there would be 3 points, 1, 2, and 3. But obviously we would have to figure it out. So we just make f of x equal to g of x.
Yes.
So x cubed plus x squared minus 2x.
Yes.
Is that what you got? Yeah, equals to 0. Take x out of the brackets and you get x squared plus x minus 2. Then you've got a nice quadratic which we can factor. So that would be x and then times x plus 2 times x minus 1.
Yes.
So now we've got our 3 points. So x equals to minus 2,
Yes.
0, and 1.
Correct.
And then you can just sub those back in to find the y values, but you've already given it, so yeah, that's good.
Right. So use the simpler equation when you plug it in, right? Use gx equals to 2x when you plug in the x value. So that
Yeah, not into f of x. That would be too long.
So you have 2 points. Now you know the integration method, right? But now we already found an expression for f of x minus g of x, and this is this expression in bold, right? This particular expression in bold is basically the function itself which we want to integrate, right? Because we want in between the two graphs. So that is the function in between the two graphs. So you don't have to recalculate this. We have done it. So, and definitely do not use the factored form because working with power function is easier than product of functions, correct?
Right, yeah.
So use the basic function. Integral is so simple as that. And now, since we found 3 points, we have to do 2 different regions. First, where they intersect, right? And the second point. These are 2 different. So now the strategy is we'll call them as area 1 and area 2. So let's say this is our area 1, for example. Let's say we call this as area 1, and that one is our area 2. And definitely, we will need to have an absolute value of this area because it is going to give us a negative value. And then we'll use, it is important to write both absolute values. Area is always positive, correct? So don't think much.
Makes sense.
Don't think much. Put the limits, which in this case you found as minus 2 as the lower bound and 0 as the upper bound, and find the integral, right? So once you find the integral, substitute this FB minus FA, you can calculate the area, right? Do your calculations. You might get, sometimes I do calculation mistakes. However, I got to this answer of 8/3. Now the thing is, we have the same function actually, So I could use the same integral. You get the idea, right?
Oh, right, yeah.
Limits will change, of course, now from 0 to 1, correct? And so we use the
Mhm.
same function and the same integral, 0 to 1 limits. And again, you find the value and rearrange and get the positive value. Perfect. So, so what I did was actually I
Yeah.
switched the function. I made it minus. Do you remember? You see this x cubed
Oh, yeah.
here minus 2x. I rewrote this as 2x minus x cubed minus x squared. I kind of flipped it, but it was not required. You understand? I did
How
first
come
case.
you fixed it?
You don't need to do it. In the first case, I did f of x minus g of x. In the second case, I did g of x minus f of x, just to get a positive value. Is that clear to you?
Oh, okay.
But
Yeah, yeah.
you don't have to do it. The better approach here is just write this as an absolute function, right? So when you integrate, you're interested in the absolute value of it. Is that clear to you?
Oh, yeah, yeah, yeah.
Just work with absolute function, and then even if you get a negative value, you have to take the positive value.
Yeah. Could
Yes,
I ask a question?
yes, please.
With oh yeah, so if so let's say we got a graph, and what happened if you have, let's say, four, so you see the shaded areas, let's say you have four of them and we got four x like points.
Yes,
How do you know in between, like, so in this case it went from -2 to 0 and then 0 to 1.
yes, yes. So,
How
so
is
when you
it?
write those x values, you put them in order. So if you put them in increasing order, it is easy to see. We could
Mhm.
have had the fourth point also, right? Some fourth point, correct. So
Yeah.
you will do two at a time, right? So first, second, second, third, third, fourth. So go from left to right.
Oh. So if we had, let's say, the fourth point being 3, you
Yeah,
have to do -2 to 0, 0 to 1,
yeah.
1 to 3. Oh,
Perfect.
so not in like pairs. You have to do it.
Yeah. Just in
Oh, okay.
pairs, right? And don't just use one function. Don't only use one function. Integrate that function. You get this result, and just change these limits. Get your results: a1, a2, a3, a4. Correct. Write down
And then
their absolute values and add them all. Done.
oh, okay.
So that
Yeah.
is so. Just do. You may just call this as a, right? For example, AI
Yeah.
you may call, right? Give it a general name, AI, right? And once you find AI, now you write A1 with the limit from -2 to 0, A2 from limit from 0 to 1, A3 from 1 to 3, and so on, correct?
All right. Yeah.
Write a general term AI, find integral, and just write it in absolute notation. Does it make sense to you?
Yeah. Makes a lot of sense.
Yeah. So point of intersection, first step. Second step is put them in order, right? And then just find an integral and the FB minus FA. You see how easy it has become to find area under
Yeah. I didn't think it would be this easy. I thought it was gonna be like really complicated because like the topic itself, the title, it's like sounds really hard, but like
Yeah.
the way you've explained it, so easy.
It's the amazing work done by your Cambridge University, people. I mean, Newton,
Oh,
I should credit them to make it so simple. And see, if you realize the number of the contribution which they have done is mainly because one of the main thing is this particular concept. Because with this concept, they have actually modeled most of the real life situations. Because in
yeah,
most real life,
bridges, everything.
you have
Yeah,
to see it, right?
that's true.
And then getting back by integration in a so simple method is like amazing.
Yeah, it really is. Yeah.
Yes. So I think they hit the jackpot while getting this. Uh, that is,
Definitely.
yeah, it makes sense, right? Now,
Yeah, a lot.
for you, Amy, I'd like you to work on this and tell me how do we solve this question. Find area enclosed by, which is a cubic function again, and a quadratic function, right? We are not giving any limits. Now tell me, how will you find area between the curves f of x and g of x?
Okay, so since limits aren't given, we would have to find the point of intersection
Yeah.
by making f of x equal g of x.
Yes.
So as you've written, it would just be x cubed minus 3x squared plus 2x minus x squared plus x. That simplified is x cubed minus 4x squared plus 3x equals to 0. take x out the brackets, and we got a quadratic, and now we can factor that out. So we get x times x minus 1 and then x minus 3. And now we can find our x coordinates. So x equals to 0, 1, and 3. And you can sub those points back into the g of x because it's the shortest, simpler, that's the word, equation. So we get our points of intersection. Now we've got that. So like Sir said, put them in put it into order, increasingly, yeah?
Yes.
So then we would just have to find the integral between 0 and 1, and then 1 and 3.
Correct. That is it. That is it. And
Yeah.
as we just discovered another method, we could write instead of a1, a2, a3, ai, general expression, f of x minus g of x, general integral. And then for each integral, we can do this part, which is fb minus fa, right? Each integral, and we can take the absolute value of that, add it up, and write down the answer. Does it make sense to you?
Yeah.
Correct. So in this case, when we did, I did get negative value for a2. So we used, since we got negative value, we used the absolute values of both to add them up and got our answer.
Yeah.
Correct. So integration, which is thought to be a very difficult topic. Oh, right. So you see, we did take good examples where we had the combination of cubic and parabola. That is,
yeah.
GCSE level A goes to up to this level actually. So this is what you get, right? As I was saying, in this particular case, there could be a variation. Let's be very clear about our variations. They can form a triangle here. Do you understand? And instead of everything else, they want area of, this portion. You're getting my point? So in the test, they will say, well, tell me the area of this portion. In that case, you work on the A area, correct?
Yeah.
I don't know. That may be slightly tricky. So look into these questions. How do we find, this is a curve. It is not a straight line here. This is a curve, okay? This is a curve, right? And so we have this particular portion. Well, this is simple. We have the point of intersection of these two, and that is simple, right? So yeah. Not that, but this is much simpler than what I thought. You understand what I was trying to say, how it is very simple?
Wait, when you mean the triangle, so I saw you put the line, but it was the shaded region. Is it just that section?
Okay.
Like so you shade it in?
Yeah, let us take another question here, which is, we are only given the cubic function, correct? Is that clear? We're given the cubic function, right? And then we want the area of, we shade this portion in green.
Oh, that portion, okay.
This, right? So that is very simple. We are given the two boundaries. It is like our question number 1.
Oh, yeah.
That one is like question number 1. Now, what we could also do here is that in this cubic function, we could connect these two. You understand? We could connect these two, and then we can ask you the area of this portion. The one which you see as the blank area. You get my point?
Yeah.
That is complicated since you have to take care of, there are some negative portions also.
Right, yeah.
You get the idea? So when you have to find that particular area, you have to see that, how do we get the area of only the upper half and the lower half with the x-axis. So you have to work with only a cubic function first with x-axis, getting these points. Is it clear to you?
Oh, okay, yeah.
This portion on the top, the blue portion. Let me show you what I'm trying to say. That is your cubic function, right?
Yeah.
And what we want is, we want to take away this area, correct?
We want to take away.
Yeah, because I want area of this blank area. Let us say blank area.
Oh, yeah. Sorry. Yeah, I get it.
You get that, Prof?
Yeah,
So
it just took me a while.
we have to take away that area. And as
Right.
far as the quadratic function is concerned, if you look at the quadratic function, so which is going through this point, right? So which is going through this point. In quadratic function, we have to find that area to be taken away.
Yeah. Because we want the blank part. Yeah, I
Yeah,
get
we
it.
want the blank part. So you separately do those small bits, correct?
Oh, and then you just subtract
Yeah.
from.
From the triangle formula, half base into height.
Oh. Oh. That's very good. Oh.
Yeah,
So
this
you have to do it in like little sections.
little section. So
Got it. Yeah.
you have to be very careful. Sometimes they'll make a sketch and kind of, they'll directly not ask you the area of between the two curves, right? The variation is that they'll make like this, but they want the other area, right? So you have to use the area of the triangle, and from that area, take away unwanted regions.
Oh,
You
okay.
have to figure out, sometimes that could be 4 different regions to be taken away using 2 different curves.
Right, yeah. So don't go like straight away trying to figure out that blank part
Yes,
because it
yes.
won't work. Okay. Yeah.
So very careful about this part. So that could be a complicated question, right? You get the idea, right?
Yeah.
So I didn't take this kind of a question in my selection of videos, but later on I'll take one to share with you. But I guess there will be some, when you do examination practice, you can get across, correct?
Yeah.
Also watch my videos on your previously solved examinations. We'll have this kind of question there, okay?
Oh, okay.
So that should be good. So almost, did you understand all this?
Yeah. It was very clear.
Okay, now tell me, what did you understand about integration right from the very beginning till now?
Okay. Right. So are we starting like formulas or?
Not really
Just-
formula, but you can tell me broadly.
Oh, okay. So let's say you've got, we're trying to find the area under the curve. Well, the formula we use is a of x equals the integral between b and a, the two limits, and then f of x with like differentiate with respect to x. And then when you do that, you would have to, like when we take our values of the limits, we subtract f of b minus f of a. So yeah, and when finding the questions we did today, like areas under the curve, if they don't specify the limits, the first step is always find the point of intersection.
Correct.
So to do that, you just make the two functions they've given equal to each other. Then we can work it out, and then you put the x-intercepts into, or the coordinates like into order, and when it's into order, then you sub those values, like you take the limits into pairs, and you put them as the limits, and then you subtract them. And we said like use the general formula a of I, and then a of I, stuff like that. Then you take the absolute value because area has to be positive, and then you add them up, and then you get the area under the curve.
Perfect. Now tell me one thing. If the question is find the integral and they do not specify area, then what will happen? How will it change? They say just find the integral and not the area. Now it is kind of important to understand that integral is also a number. So when you find within these two intervals, you'll get a number that could be negative also. So we don't have to do the absolute value. So
Oh.
the integral will be positive or negative. You understand?
Oh, okay. Yeah.
So that is kind of important to understand. So if they specify area, then you have to always do negative and positive part. Like in the last example, we had a negative part also and a positive part, right? If they find the integral, we'll not get this bigger answer. We'll get a1 minus a2 as our answer, right? Then don't do absolute values.
Oh, so when it says find the integral, all you need to think is that it has to be a value. It can either be positive or negative. But if it's area, it has to be absolute value.
Yes. Yes.
Oh, got it.
So many times they'll just give you a simple graph, and from the graph they'll say find the integral between a and b. Then you have to divide the portions saying, well, this is my positive, this is my negative, that is my positive, and then add them all without taking absolute values. They're not saying area. Okay, so you have to be careful. Integral is any value, any real number, but area is always a positive number.
Right? Makes sense, yeah.
So keep that in mind, and with that, I think you should be in a position to do all the questions. And if there is any difficulty, just share with me. And I'll post you as we came across a question which could be very tricky. Finding the
Triangle.
triangle type.
Yeah.
So I'll look into that part also. If you come across, share with me. And
Yeah, definitely.
right. So I think next topic we can decide some of the chapter in your grade 12. I mean year 12, GCSE level A. They're only going up to this portion, and we did some extra because we went into fundamental theorem of calculus, and I think that gives you better sound knowledge. Why are we doing like that? You get the
Yeah,
idea?
yeah.
So that was
So
the thing. Yeah.
is the fundamental like theorem things not in my book then?
I didn't
Or
see.
did you just go, oh, okay, so you just went ahead. Okay, yeah.
But I feel that
That's good.
important. No, the pages which you shared with me,
Yeah.
in pages it wasn't there. But I thought that it is kind of necessary to get the foundation and moving.
Definitely.
You can appreciate it much more than. That's why we combined all the three things together. The concept of antiderivative dA dx equals to f of x. That means integral is the the derivative of the function itself. We are looking into antiderivative, and this formula fb minus fa gives us everything, right?
Perfect. Yeah.
So we understand exactly how those things were derived, and then we can appreciate and do it further, right?
Yeah, and there won't be like any gaps or anything because I'll be like wondering what is happening. Yeah.
That is true.
So it's good
It's a
to see.
mechanical exercise. I mean, which you can't appreciate while moving forward.
That's true. That's true.
Right. So, Amy, that was great. Did you understand everything today?
Yeah, it was really good. Now I feel like everything's really clear in my head about the whole like topic so far that's in my book. So I'm just gonna go attempt some questions. I feel really confident. So yeah,
Perfect.
thank you.
With that, all the best. Keep attempting all the questions. Once you're done, share with me any difficulties, and then we'll move forward. Okay?
Okay. Thank you so much.
Thank you. My pleasure. All the best.
Thank you.
Yeah.
Bye.